All right, let's recap what we know so far. For starters, electricity is just electrons in motion, and circuits give those electrons a path to move. They move from a higher concentration or a more negative area to areas of lower concentration or a more positive area. And last but not least, in this course, we're using conventional current flow, where current moves from positive to negative. We're almost done laying down the groundwork. There's just one more mystery we have yet to uncover. What makes electrons move in the first place? Yeah, we know electrons are attracted to the positive terminal of our battery or of a power source, but with how much force are those electrons pushed out the battery? How badly do they want to get to the other side? And what's slowing them down from getting there as fast as possible? That's where we introduce voltage, which is the push or pressure that moves electricity. Next, we'll be talking about current, which is the actual movement of charge. Last but not least, we'll be talking about resistance, which is anything that slows down that movement. And to help explain all of this, we're going to be using one of the best analogies in electronics: water. Because believe it or not, electricity and water behave in surprisingly similar ways. Let's head to the lab. Cool. I hope you're a really big fan of our super high-tech setup right here. Let's go over what everything here is. This water bottle right here is the equivalent of a battery, and this tubing represents our wires. This knob right here is basically a switch. It will only let water or electricity flow when you turn it and you let things go through. And this cup right here, that's where electricity wants to flow. Okay, now let's talk voltage. Think of it like water pressure. If our water bottle is filled up high, there's a lot of pressure at the bottom. Just like water gets pushed through tubing, voltage pushes electrons through a circuit. The key idea here is the higher the water level, the more pressure at the bottom. And the higher the voltage, the stronger the push on the electrons. If you see anything start leaking, no you didn't. Okay. Now, let's open the valve and see the water flow. As soon as we open the valve, the water starts flowing through the tubing. This is like connecting a battery with wires. The water represents electric current, and current is the flow rate of electricity. The more pressure or voltage, the faster the flow. Great, now let's turn it up a notch. Let's say we have two paths that we can travel. One is the normal same size tubing, but now we're going to replace one of the tubes with a smaller, thinner one to simulate resistance. Watch what happens. So this tubing right here on my left-hand side is the skinnier tube, and this one is the regular tube. Here we go. Look at the difference of water in each cup. The bigger tube means fast, free flow, no blockage, whereas the narrow tube means slower, restricted flow. The key idea here is low resistance makes it easy for current to flow, and high resistance makes it harder for current to flow. This one right here on the right-hand side is less resistance with the fat tube, and this one has a skinnier tube, so more resistance. Electricity behaves in the same way. If the wire offers little resistance, electrons flow freely. If it's more resistant, they slow down, just like water through a tiny pipe. Okay, now let's repeat the experiment. Each time I refill the water to keep the flow going. I'll let the flow keep going. I'll just keep refilling it. I won't even stop the flow. Oh. Again, the water mainly went into this cup, the one that offered less resistance. Water always flows from high pressure, the bottle, to low pressure, the cups. And once it hits the cups, it's lost that pressure. And to keep that system going, I refill the bottle, raising the water back up to its higher pressure or potential. And this is exactly how a battery works. The key idea here is a battery is like a pump. it pushes electrons back up to a high energy level so they can keep flowing. So basically, I act like the battery. Now, let's throw in another challenge, a sand barrier inside the tube. Beautiful. And now onto the last phase of our challenge today. What do you think would happen if we added a sand filter in between the cup and the water bottle? Let's find out. Okay, let's run the experiment. I'm gonna hold this for safety reasons. Great. So if I open the knob, drip, 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 and drip. Okay, I don't know if it's very easy to see through the camera, but the water is dripping ever so slowly down there. The water still flows, but it flows much slower because it's constantly bumping into sand particles trying to get to the other side. And that's exactly what happens with electrical resistance. In good conductors like copper, electrons move freely. In resistors, or poor conductors, electrons get slowed down by collisions, just like water through sand. Now, imagine our light bulb is this sand filter. What happens to the energy? Just like water loses energy pushing through sand, electricity loses energy when it encounters resistance. And that energy gets converted into heat and light. So the key idea here is resistance slows down current, and higher resistance means more energy lost as heat or used as light. Cool, so let's put everything all together. Voltage is like water pressure at the top of a tank, the push behind electron movement. And current is the flow of water, the movement of electric charge. Last but not least, resistance is like a narrow pipe or a sand filter in the flow. Anything that resists current. And the battery is just a pump that energizes the electrons and keeps the flow going. To keep it short, voltage is the pressure. Current is the flow. Resistance is the obstacle. The battery is the pump. Understanding these three is fundamental to all of electronics. Try this experiment at home, grab a bottle, some tubing, and a basin or two, and post your setup online. Tag us at Horizon Robotics Lab on Instagram, TikTok, or Twitter. I'd love to see what you come up with. Next time, we'll dive into our very first lab, where we'll build real circuits and finally see voltage, current, and resistance come to life together. Roll up your sleeves, we're about to build some cool stuff. See you next time. If you like what you've seen so far, you should visit our website and check out our electronics and coding kit. It comes with all the videos, all the lessons, all the code, all the labs, and all the project files. So yeah, link in the description and happy learning.